Properties of waves. Waves will act in different ways when they strike objects or boundaries between different media. They can be, a lot of things ending in ed here, reflected, absorbed, transmitted, refracted, diffracted, interfered. Clearly, we're now going to go over each one of those. We'll start off with some pictures. Reflection. Okay, we have light coming in like this, hits a mirror, bounces out. We have absorption. We have white light coming in, and maybe you learned earlier in your science classes that white light is really composed of all the different colors of light. They all hit a green surface. Only the green light is reflected, all the others are absorbed. Then we can have transmission. The light just goes right through and doesn't change. Now some cooler things that waves do. Waves can refract, and that's basically a fancy word for bend. The wave comes in like this from the air, it hits glass, it bends, and then it leaves the glass and it bends again. We have diffraction, which is a different kind of bending. We have the waves coming in like this, all parallel to each other. They hit this little opening here, and then they start off again like someone had dropped a rock here, like we started at the first part of this unit. And it generates more bendy lines. And a cool thing is if you go far enough away, they look like they're straight again. Then we have interference. And you can't see it here, but there's two holes for the waves to go through. They each regenerate just like they did over here, but then they interfere with each other, which means they get bigger and they get smaller at different parts. And we'll explain more of this as we go on. When a wave is reflected, it is bouncing back off of a boundary, like a lake surface. So here you would have light coming from the sun, hits the water there, bounces this way, or it bounces off the mountains and then goes into the lake. So that's called reflection, where you change surfaces. And of course, bouncing off a mirror is also a good example. Another type of wave is sound waves. They can bounce off a wall and then they come back and you can hear what you said. Both light and sound have wave properties. We'll discuss these in later chapters. Reflection. Let's talk about the behavior of a Springs wave. So we have a Springs wave pulse as it strikes a wall, and this will help us understand reflection, hopefully. Please access the below video from UCLA and observe the following. The fixed end of a spring, which is going to be the top one, is attached firmly, stuck to the wall, and the end can't move. The free end of the spring, the bottom, is attached to a ring that can slide up and down on a rail. So we're going to have two different cases. One end of the spring is attached firmly to a wall, and the other one is attached to a ring so it can move up and down. So please watch the video and think about what happens to the pulse as it strikes the boundary, the wall, for each spring. Please go to the next slide for the answer. For the fixed end, the pulse bounces off, it reflects from the wall, and returns upside down. It inverts, right? Invert, fancy word for upside down. Free end, the pulse once again reflects off the wall, but remember it's on a little ring that can go up and down. This time, it returns upright. Can you think of a reason the return pulses are different? Okay, absorption. When waves hit a boundary, not all of it is reflected. Some of the wave is absorbed by the boundary or the other medium, so we call that absorption. The amount of the wave that is reflected and transmitted depends on the type of wave and the medium it hits. White light is actually made up of all the colors, and we already talked about that. Here's your white light coming in. The green part of the light is reflected, so your eye sees the surface as green. All the other colors are absorbed, so you don't see them. The energy of a wave decreases as it is absorbed by the medium. Where's that energy going? It's increasing the energy of the medium. If you're out in the sun, you absorb the light rays from the sun and your skin warms up. And please be careful. When you're out in the sun, have sunscreen on or have shirts on, something that protects you. Why is that? You don't want that energy being absorbed by your body too much. It can do bad things to it. Now, let's take a more peaceful one. Someone is yelling at you from far away. Some of the sound wave is absorbed by the air molecules, so you don't hear them very well. The energy of the air increases, but it's not by a very large amount because there's so much of the air, but you just can't hear as well from somebody further away or farther away. Okay, we're now on our third type of interactions with waves. We talked reflection, we just did absorption, and we actually already talked about transmission when we talked absorption. Some of the light goes through the medium, and we call that transmission. The amount of the wave that is reflected, absorbed, and transmitted, it all depends on the type of wave and the medium it hits. For the glass below, all of the light is going through the medium, and none of it is reflected or absorbed. In real life, though, you're always going to get some reflection here, but we're assuming somehow we've got a perfect glass that doesn't have any reflected light, or any light that gets absorbed by the material here.